today's video, we'll be going over solubility, which is closely related to intermolecular forces. First, let's define solubility. Solubility is the ability of a substance, called solute, to dissolve in a solvent, which is usually a liquid. When a solute is dissolved in a solvent, we call this a saturated solution. However, not every solute you put in a solvent will be noticeably soluble, as you already know. If this was the case, how would beaches work? If all the sand was just dissolved into the seawater? The beach is interesting to note though, as the water is a solvent for sodium chloride, also known as salt. We must understand what being soluble means before investigating the salt and sand within water. When a compound is soluble in a liquid, the liquid molecules are able to form bonds around the compound, incorporating it into the liquid, making an aqueous substance. The solution will consist as a homogeneous mixture, meaning that at every level the solution will be essentially the same makeup and relative concentration of solvent to solute. An interesting way to identify a solution is if it cannot be separated by a filter or any other mechanical means. Even putting salt water through a filter will get some larger salt molecules, but the salt concentration of the filter water will still be relatively high. So why does salt dissolve into water while sand remains undissolved within the water? First, the relative solubility of these solutes is not the same for every solvent used. They will actually vary depending on the solvent, so sodium chloride and other salts will not always be more soluble than sand. The general rule for solubility is like dissolves like, so this explains why a polar solvent like water easily dissolves sodium chloride, a very polar molecule. But glucose, a less polar compound, doesn't dissolve easily within water, as it's a polar and covalent mixture. Polar dissolves polar due to the dipole attractions, as the solvent aligns itself where the positive dipoles will align around the negative dipoles of the solute and vice versa. But if a covalently bonded solute is put in a polar solvent, the polar solvent will not be able to surround the non-polar solute, as the charges will not be compatible for bonds. To clarify my earlier idea of a solute being soluble, almost every solute and solvent combination is soluble to an extent, but some are more soluble than others, meaning the solvent will have a higher capability of dissolving the solute. This is all based on the equilibrium of the solute and solvent combination. In a later video, we will go into more depth into what equilibrium means, but for the concept of solubility, a higher equilibrium constant, denoted as K subscript SP, means a higher solubility factor, and a lower K subscript SP means a lower solubility. Once again, this was J&A Chemistry. I hope you learned something about solubility. Have a nice day.